Decomposing fractions into partial fractions. In this video, I will take a look at why we treat recurring factors as I did in the previous videos. When I consider the fraction 3x minus 2 over x squared minus 2x plus 1, I see that the denominator can factorize as x minus 1 squared, and I therefore have one linear factor that recurs twice. If we would now write our denominator as x minus 1 times x minus 1, and if I could now treat my recurring factors as I would treat distinct factors, I would then decompose this fraction into two parts, both with denominator x minus 1. Since the denominators are both of first degree, the numerator must be constants, say a and b. If I now multiply the equation both sides by the LCD, x minus 1 squared, and simplify, the left-hand side becomes 3x minus 2, and the right-hand side equals ax minus 1 plus bx minus 1. If I now simplify the right-hand side of equation 1 and regroup the terms, it will give me that 3x minus 2 is equal to a plus bx plus negative a minus b. Comparing the coefficients of x, we see that a plus b is equal to 3, and comparing the constants give me that minus a minus b is equal to negative 2. If we solve these two equations simultaneously by adding the equations to each other, we get 0 is equal to 1, which means there is no solution for a and b. This implies that we cannot find any decomposition of 3x minus 2 over x minus 1 squared of the form a over x minus 1 plus b over x minus 1. This should have been quite obvious from the start, because if we try to add a over x minus 1 to b over x minus 1, we can see that the denominators are already the same. So the lowest common denominator is x minus 1. So a over x minus 1 plus b over x minus 1 is simply equal to a plus b over x minus 1. This is a problem since the denominator is not equal to x minus 1 squared as in the original fraction, and therefore a over x minus 1 plus b over x minus 1 can never equal 3x minus 2 over x minus 1 squared. So treating recurring factors as we treat distinct factors does not work. If I now reconsider the fraction 3x minus 2 over x minus 1 squared and decompose it into two parts, one with denominator x minus 1 and the other one with denominator x minus 1 squared, the numerator of x minus 1 should be a constant, say a, but what should be the numerator of x minus 1 squared? If I reasoned that x minus 1 squared is x squared minus 2x plus 1 and is therefore quadratic, I would then have to make the numerator of x minus 1 squared of the form bx plus c. If I now multiply this equation both sides by the LCD, x minus 1 squared, and simplify, the left-hand side is 3x minus 2 and the right-hand side is ax minus 1 plus bx plus c. If I simplify the right-hand side of equation 1 and regroup the terms, it will give me that 3x minus 2 is equal to a plus bx plus negative a plus c. Comparing the coefficients of x, I see that a plus b is equal to 3, and comparing the constants gives me that minus a plus c is equal to negative 2. If I try to solve these two equations simultaneously, I realize that I have three unknowns, a, b, and c, but only two equations, which means that I cannot find a unique solution for a, b, and c. So this decomposition is not quite suitable for decomposing this fraction, as it will be very difficult to find a combination of a, b, and c that works for integrating purposes, and it will be time consuming. So if I now consider the fraction 3x minus 2 over x minus 1 squared again, and again decompose it into two parts, one with denominator x minus 1 and one with denominator x minus 1 squared, then the numerator of x minus 1 should again be a constant, say a. But what should the numerator of x minus 1 squared be? If I now reason that although x squared minus 2x plus 1 is quadratic, but it is the power of a linear factor, and therefore focus on the fact that I have a linear factor, I could then make the numerator a constant, say c. If I now continue to multiply my equation on both sides by x minus 1 squared and simplify, the left-hand side is 3x minus 2 and the right-hand side is a x minus 1 plus c. If I simplify my equation on the right-hand side, it will give me that 3x minus 2 is equal to ax plus c minus a. Comparing the coefficients of x, I see that a is equal to 3, and comparing the constant, it gives me that c minus a is equal to negative 2, but remembering that a is already equal to 3, I can calculate that c is equal to 1. So we seem to have a decomposition of 3x minus 2 over x minus 1 squared as 3 over x minus 1 plus 1 over x minus 1 squared. We will only know for sure that this is correct if we test our answer by adding the decomposed fractions 3 over x minus 1 plus 1 over x minus 1 squared. We'll have to multiply the 3 over x minus 1 by x minus 1 over x minus 1 to get a common denominator. If we then add the fractions, it will give me 3x minus 3 plus 1 over x minus 1 squared, which simplifies to 3x minus 2 over x minus 1 squared, which is my original fraction. And therefore, this method of decomposition works.